All right, what's up, math scholars? I've got good news for you. 9-1, day 2. Pretty sure you've learned everything in this lesson last year in geometry, and maybe even done it the year before in Algebra 1. So how many of you have solved triangles that look like this in geometry class last year? Sweet, and happy we're in geometry right now. And how many of you remember solving them in Algebra 1? Maybe some, maybe not some. I do see one hand, but he took Algebra 1 in a different state. So, okay, the first stop we need to do is go head to the mode button in your calculator. Everybody hit mode in your calculator. If you left your calculator at home in your room, you're going to have to do that before you use it on a homework like this. All right, so you're all in mode. You want to scroll or look down with your eyeballs to where it says radian in degree. Most of you probably have radian highlighted right now. We need degree to be the one to highlight it. So you just take your cursor down there and you click enter, and that's as easy as it is. So you'll find out real quick if you're in the wrong mode, because you won't be getting the same answer we're getting. If you got yourself into degree mode, can you check to make sure your neighbor got themselves into degree mode? It'd be a helper out. Okay, people on the internet, we are doing our first triangle. So we played a game that's not included on the video, and the game was called What Would You Use? And the students just glance at a triangle like this, and I told them in 10 seconds or less, you should know whether it's sine, cosine, or tangent. And the strategy I told them is look for that hypotenuse. Can everybody point to our hypotenuse right now? Everybody's pointing up here at the 8, right? So since we definitely have a hypotenuse, we're either going to use sine or cosine, because tangent doesn't utilize hypotenuse, okay? So really, we just need to decide, is x an adjacent or an opposite side? What do you guys think? Adjacent. So everybody should be selecting cosine. So here's how the setup would look. You want to take cosine of your angle. So your 30 needs to be right here. You never want to put a side measurement beside a cosine or a tangent. Or a sine. So cosine of your angle 30 degrees equals adjacent over hypotenuse. And that is your setup. Any questions on our setup? All right, solving for x is going to be a breeze. I'll get a different color. I need to move my 8 to the other side. So how will we move it? Multiply. So as far as what will you type in the calculator, you'll type in 8 times the cosine of 30. And this is a great time to check to see if you get the same answer I get. So if you get the same answer I get, you're in the right mode. 6.93. A lot of these are yucky answers, so just go with rounding to the hundredths place. Very good. Everybody was in the right mode, and it worked. Sweet. All right, we are looking at the Lighthouse problem. We don't have a variable yet. We need to put a variable there. So let's read our question. Which of these is the nearest, or which of these is nearest to the height of the lighthouse? This used to be a multiple choice question. That's why it's worded like that. But should I put my variable along this dotted line, or should I put my variable along the lighthouse? Right, you're looking for the height. All right, point to your hypotenuse, everybody. Are y'all pointing up here to the dotted line? Good, so we are not using tangent because we don't know anything about our hypotenuse. What is x, opposite or adjacent?
Wait, yeah, you said...
We would not use tangent. We would not use tangent. Oh, I'm sorry, we would use tangent. I don't think my brain and my mouth are communicating properly today, so I apologize to everybody watching this video. We would use tangent. Okay? My bad. All right. I know, I just need to take a break and tell my mouth to communicate with my brain. So tangent 26 is, I was in the middle of labeling. X is my opposite side, right? And 90 is my adjacent side. So tangent of 26 equals x over 90. That's my setup. The pink is my setup. Is everything looking good? I appreciate you guys staying on top of all my mistakes, because they're coming at us today. We're going to need to move that 90 to the other side, so what should we do? Multiply both sides by 90. So as far as the calculator is concerned, 90 times tangent 26. 43.90 if you want to round to the nearest hundredth. All right, we are doing this one. It is a right triangle. All of these need to be right triangles, or we would not be allowed to use these methods like we're using them. Can you point to the hypotenuse for me? Perfect. X is my hypotenuse. Would 13 be an opposite or an adjacent? Opposite. It's all the way across from the 22. So we should probably use what? Sine. Good. Sine of angle 22 equals opposite over hypotenuse. Now, these ones cause headaches near and far because you have a variable in your denominator. It is bad news to have a variable in your denominator. So a good goal for you should be to get that variable out of your denominator as quickly as possible. How could I get my x out of my denominator? Come on, Nick. Multiply both sides by x. That will cancel it, and it'll be up in the land of the living now. No longer down in the denominator. Here I'm solving for x. I want to get x by itself, so that sine 22 needs to move. Nick? Yeah, we're going to divide that sine 22 over to the other side. So as far as the calculator is concerned, type in 13 divided by sine 22. And you don't need to close that parenthesis off. Somebody asked me if you'd had to. You don't have to. 34.7. I do want to have a brief discussion about something with capital letters and lowercase letters with you that will be true the rest of the chapter. That is this. If you ever see a capital letter, it's an angle measurement. So see how they do capital B is 45? If you ever see a lowercase letter, lowercase c, then that is going to be a side measurement. Cool. That's just a thing that they like to do in math to keep the sides and the angles different. I wasn't going to do this, but since I see people writing, let's go ahead and do it. They told me that capital B is 45. I would go up to B and I'd stick that 45 right here in this corner. That's an angle. And they told me that lowercase c is 5. You know what I almost forgot to mention? Huh, that's rude. That lowercase c always lives across the triangle from angle capital C. And same with B. Lowercase b lives across the triangle from uppercase B. Did you see that in geometry before? Or not? No, so it's a new thing this year. It's going to be used for the rest of the chapter. And capital A is across from lowercase a. Just looking it up. They do say solve the triangle. That means find all sides and all angles. Not as hard as you would think. How could I find angle A down here in this lower left corner? Yeah, all of our triangles have 180 degrees, so this is a 45, 45, 90 triangle. So you don't actually need trig to solve this. Couldn't I use the Pythagorean theorem? Since this is a 45, 45, 90 triangle, it doesn't look like it, but A and B have to match. We can just call them both x and use the Pythagorean theorem. X squared plus x squared is 5 squared. I actually like this problem because we can talk about what x squared plus x squared is, because my last class forgot. 2x squared, you guys remembered. And then how would I move the 2 to the other side? So that would give me x squared equals 25 over 2. And how do I finish? Square root. Now we don't have to worry about any negative answers because we can't have negative side measurements. I'll just do positive answers. The square root of 25 is 5, and the square root of 2 is a really yucky number, so I'll just leave it as radical 2. That would be what both legs measure. Leg B and leg A. Moving on, we got an angle of depression and an angle of elevation. We're not actually going to do a problem with this, but I wanted to refresh it in case, you know, you see it in the ACT or maybe in the math homework next week. Angle of depression is if you're standing up on top of a building looking downwards. It's this guy. And angle of elevation is if the guy is standing on the ground looking up at the building. It's this guy. And those two are equal. Do you know why they're equal? They are alternate interiors. Good job, geometry scholars. So we're going to be done. It is a worksheet, and if you need a copy of the worksheet because you're at home absent today, it's going to be the last couple slides of the notes. So just look. You're going to go all the way down to get to the double bar line, and that's give you your indication to stop. Okay? So thanks for watching the video at home today. Goodbye.